Today, we're here to talk about acid rain. Now, what is acid rain? Acid rain is the sulfuric and nitric acid that falls to the ground in the form of rain, dust, hail, fog, and snow. Sulfur dioxides and nitrogen oxides enter the atmosphere and travel through wind currents until they react with oxygen, water, and other chemicals to form acids to fall to the ground. Acid rain is produced from many different sources, but one of its most prevalent sources is the burning of fossil fuels. Some examples of burning fossil fuels are vehicles, electrical power plants, heavy equipment, oil refineries, and manufacturing industries. Some natural sources of acid rain include volcanic eruptions, lightning strikes, and methane and carbon dioxide emissions from vegetation. There are two different types of deposition from acid rain: dry deposition and wet deposition. Wet deposition is commonly known as acid rain, falls to the ground mixed with acids in rain, snow, hail, or fog. Dry deposition has an absence of moisture and falls to the ground in the form of gas and large particles. These particles then get washed away by rainwater and mixed into wildlife. Dry deposition is extremely harmful to human health, vegetation, and natural habitats. The chemical equation of acid rain begins with CO2 and H2O yielding H2CO3. Now what that means is that carbon dioxide in the air dissolves into rainwater to yield carbonic acid. Carbonic acid then decomposes into hydrogen ions and HCO3, which is bicarbonate. Hydrogen ions dissociated from carbonic acid lower the pH level in rainwater and bring it down to 5.6, making it slightly acidic. This slightly acidic solution is responsible for reacting with calcium carbonate that is found within limestone. The reaction between calcium carbonate and an acid such as carbonic acid form limestone and is responsible for the making of caves in limestone rock areas. As the years go on, our rainwater has become more acidic because we have continued to burn more and more fossil fuels. The burning of coal and electrical power plants is one of the leading causes of sulfur dioxide emission into the air. Sulfur dioxide and sulfur impurities are also produced when crude oil is burned. Sulfur from the burning of fossil fuels combines with oxygen in the atmosphere and forms sulfur dioxide. The equation is S plus O2 yields SO2. Sulfur dioxide is then released into the air and reacts with oxygen and water to form sulfuric acid, H2SO4. The sulfuric acid produced has a pH level of 3 and is a strong acid. pH levels is a scale used to measure how acidic or how basic a solution is. It runs from the numbers 1 to 14. 1 through 7 are the acidic levels, and 7 to 14 are the basic levels. The lower the pH of a substance, the more acidic it is. If you have more hydrogen ions in a substance, you will have a lower pH. For example, pH 4 is 10 times more acidic than pH 5. Sulfuric acid completely ionizes into hydrogen ions and decomposes to 2H plus SO4. The ionization of hydrogen ions causes the rainwater to be below 5 on the pH scale, which causes damages to buildings and statues, particularly in limestone, and can kill trees and crops, and can kill fish and other wildlife, and can harm human health. Another cause of acid rain is lightning strikes, which emits nitrogen. Nitrogen combines with oxygen in the air and forms NO, which is nitric oxide. Nitric oxide then combines with oxygen in the air to form nitrogen dioxide. The acid then dissolves in the moisture in the air and forms 2HNO3 and NO, which is nitric acid and nitric oxide. Acid rain destroys our habitats and should be prevented. There are ways to prevent acid rain, such as using other sources of energy besides coal. Energy plants can reduce their use of burning coal and start using wind and water for power plants and electricity. We can also reduce our pollution. What are you going to do to stop acid rain?